So before we move on to implicit, I want to talk about just your general stuff that we've done so far. So we know how to do a constant multiple rule. We know how to do sum and difference. We know the product rule. So like the derivative of the first times the second plus the derivative of the second times first. We know our quotient rule. Constant rules are trig rules, and of course our power rule. And we always need to be concerned about the chain rule. All right, so something's going to pop out. All right, so now we are on implicit differentiation. This is 2.5a, if you take notes that way. And I need a really good reader, and Luke is my guy today. Here we go.
Most functions that you have dealt with in your math career have been in explicit formula. Solve for y.
All right, so most of all of your math from until now is basically like you go out an x, you go up a y. You go out an x, you go down a y. That's everything that you've pretty much done so far. It's a nice, good function, and it's good. However, not all relations are like that. And so when we look at this, if we have like x, y equals 1, this is an implicit form because x's and y's are together. However, you can actually solve for y on this one by just dividing by x. So now we can have like the explicit form that you're used to, y equals 1 over x. And then you could take a derivative like we normally would. All right. However,
what if you cannot manipulate the function so it is solved for the y value? Then you must use implicit differentiation. How would you solve for dy dx?
Oh no, that's what we're going to learn today. All right. So if we look at this relation, all right, this equation, can we solve for y?
Why not?
You can't. You can't solve for y. So we can't actually put it in explicit form. We actually have to keep it in implicit form. All right. So this first one, I am deriving with respect to x of x cubed. And so we should know how to do this. We're deriving x cubed with respect to x. And so what's the 3x squared, right? And what's really happening behind the scenes is I took a derivative of x with respect to x. So technically a dx over dx pops out. But we don't actually put that. Because why? What does dx over dx go to? It goes to 1. So that's why we didn't put it before. All right. However, if we look at this next one, I'm deriving with respect to x, y cubed now. Do you see how my variables don't match? You see how one's a y and one's an x? I'm taking a derivative of y with respect to x. And so my variables disagree. And so what's the derivative of y cubed? It's the same power rule. It's still what? 3y squared. However, what did I just take a derivative of? Y. And so that's why I have a dy, and I'm taking it with respect to what? My command was ddxing it, so what am I taking it with respect to? Dx. X. So that's why a dy dx pops out, because my variables don't match. All right, let's do it again. And so now I'm taking a derivative with respect to x of x plus 3y. So what's my derivative of x with respect to x? 1. Just 1. Now, technically, behind the scenes, a dx over dx happened. But do I need to put that? No. No. So now, plus, what's the derivative of 3y? 3. Just 3. But do my variables agree? No. And so what did I take a derivative of? Y with respect to x. So a dy dx popped out on that one. All right. So let's look at this next one. I'm taking a derivative with respect to x of the product xy squared. So what rule do we actually need to use on this one? The product rule. So let's go over it again. So the derivative of the first, what's the derivative of x? 1. And then times the second, which is y squared. Plus the derivative of the second. What's the derivative of the second? 2y. But what needs to be popping out? A dy dx pops out, because I just took the derivative of y with respect to x. So that's the implicit differentiation happening. And then times the second, or times the first, which is x. However, if you're looking for a multiple choice answer, they're going to put it in like in order. So they're going to have like y squared and then plus 2xy dy dx. Like that will be the answer that. So we're going to find dy dx on the relation y cubed plus y squared minus 5y minus x squared equals -4. We're going to take the derivative. We're going to find the derivative. This is still dy dx, just like before. That is the slope of the tangent line. And so let's take our derivative with respect to x now. So what's the derivative of y cubed?
3y squared.
3y squared dy dx. And then plus, what's the derivative of y squared? 2y dy dx. And then what's the derivative of -5y? -5 dy dx. And then what's the derivative of -x squared? -2x. It's technically dx dx, but do we put it? No, because the variables agree. And then is equal to what? 0. All right? Because the derivative of any constant is 0. And so now what we need to do is we need to solve for dy dx. And so if you look at the guidelines, if you wanted to read them, you're more than welcome to. But we need to get dy dx on one side of the equation and everything else on the other. So I want these three on one side and I want this guy on the other. So what do we need to do with -2x? We need to add it to the other side. And so now we're going to have 2x on this side. And then we need to factor out dy dx on those. And so now we'd have dy dx times 3y squared plus 2y minus 5. So now, how do I actually solve for dy dx? What's dy dx in that quantity doing? They're right now being what? Multiplied. So what do we want to do? We want to divide. So now we have dy dx is equal to 2x over 3y squared plus 2y minus 5. So we're going to determine the slope of the tangent line. So what is the slope of the tangent line? A derivative. So we're finding the derivative of this equation, x squared plus 4y squared is equal to 4 at the point square root 2 comma -1 over square root 2. How do we get to slope? We take a what? Derivative. So let's do it. So what's the derivative of x squared?
2x.
2x. Plus, what's the derivative of 4y squared?
8y.
8y dy dx is equal to 0. All right. And so now I'm actually solving for a slope at a point. And so now I need to solve for what? Dy dx. So what do I need to move on the other side? 2x. So now I have 8y dy dx is equal to what? -2x. And then I want to divide by what? 8y. So dy dx is equal to -2x over 8y. Now, if I weren't utilizing this equation, I would kind of leave it. However, I'm going to use it, so I'm going to simplify it. What does it simplify to? -x over 4y. All right. And so now I need to find my derivative at a point. So before I do that, you guys remember when we notated a derivative, like when we had dy dx, we'd have a bar and then like x equals something?
Yes.
Well, now guess what it needs? That was when it was only in terms of x. Well, now this derivative is in terms of what? X and y. And so it's not just going to be an x equals now, it's going to be an ordered pair. All right, so that's the notation that we need to give when we give a derivative in this kind. All right, and so now we find a dy dx at the ordered pair square root 2 comma -1 over square root 2. So in my numerator, I now have what? Negative square root 2 over, so now I'm having 4 times -1, which is -4 over square root 2. And so now I have to simplify this up a little bit. Dividing by a fraction is really multiplying by its what? Reciprocal. So I'm really multiplying by square root 2 over -4, which is going to give me what? -2 over 4, which we can simplify to? Oh, sorry, it's -2 over -4, which is really what? 1/2. All right, so this is a freestyle one. We are going to find the derivative of 3x minus 2x squared y cubed equals 3 minus y squared plus 4x squared. All right, so what's the derivative of 3x? 3. And then what's going to happen on this next term, this negative 2x squared y cubed? What's going to happen there? What do I need to use? The product rule. And so what's my first? Negative 2x squared. I would highly recommend you keep that negative with your first term so you don't have to carry out that the distribution of that negative. All right, you're going to make less mistakes that way. And so then what's the derivative of my first?
Negative 4x.
Negative 4x. And then I multiply it with what? Which is y cubed. Beautiful. And then what's the derivative of y cubed?
3y squared.
So 3y squared dy dx. And then times what?
Your first is negative 2x squared.
Negative 2x squared. And then what's the derivative of 3? 0. So that goes away. And then what's the derivative of negative y squared?
Negative 2y.
Negative 2y dy dx. Okay, because my variables didn't agree again. And so then plus 8x. All right. And so what we need to do is we need to get dy dx on the same side. Now, it doesn't matter which side of the equation it is. I'm personally going to put dy dx on the right side because all I have to do is move 1. And then I can move this 8x on that side. Okay, if I were to actually move dy dx over here, I'd have to move both of those over there. It's not a big deal. However, I always like to make it easier on myself. All right, so I'm going to move this guy over here, and I'm going to move that guy over there. All right, and so now I end up having 3 minus 4xy cubed, and then minus 8x is equal to, now I have negative 2y dy dx.
Minus 3y squared.
And then, what does this simplify to first? This is a 3y squared times negative 2x squared. And so negative 2 times 3 is what?
Negative 6.
Negative 6. So really I'm doing what? I am adding 6. And so now I'm adding 6x squared y squared dy dx. So now I need to solve for dy dx. Now, could you factor out this dy dx to do another step?
Yeah.
You're more than welcome to. However, you guys are really smart people. And so what do we have up top? We have 3 minus 4xy cubed minus 8x. And I'm dividing it by what? Negative 2y and then plus 6x squared y squared. And that is what my slope is equal to. All right, there we go. Just a little bit.